Hi, let us see about different metrics for a classification task. So generally, let's say I have a classification model and let's say I am dealing with a binary class, that is I have class 1 or class 0, and let's call it as a positive class and this is negative class. So the model can predict any of the records as either as positive or as negative. Let's say the model is predicting a record as positive, right? And now there are two possibilities. Either the prediction can be right or the prediction can be wrong. Similarly, a model might predict a record or an input as negative, and even this, the prediction can be right or the prediction can be wrong. So there are totally four possibilities. Okay, so now based on these, how can we evaluate the performance of a model, that too is specifically a classification model? How can we evaluate the performance of a classification model? So there are some metrics using which we can do that, and let us see those metrics. Firstly, we should understand about confusion matrix. Let's see what is this matrix about. So let's say I have a matrix like this. Let me draw this quickly here. And let me call this as positive class, this as negative class. Before that, let me say this is where my actual values are and this is where my prediction values are. Okay, and here I have the positive class and I have the negative class. Positive, negative, and here I've got again positive and negative. So it simply means that, so model will do some predictions and it could be positive or it could be negative, and similarly there will be some actual values, it could be positive or it could be negative. Now let us try to understand and try to fill this particular table over here. So let's say my model is predicting certain records as positive class. Okay, so let me fill that. So the model is saying that this is positive class. Okay, and since here these are the model predictions, so this is positive and this is positive, and these are the model predictions which it is saying as negative. So this is negative and this is negative. Okay, now let me compare it with the actual values, right? With the actual values, so model has predicted some records as positive. Okay, and the actual also turns out to be positive, so this would be termed as true positive. The predictions are positive and those are true. Actually also they are positive, that's why this is called as true positive. And now there could be some records where the model will predict them as positive class, but actually they might be belonging to negative class. So these are false positives, that is the predictions are false. The prediction is that they are positive class, but that is false because the actually they are negative, they are belonging to negative class. Similarly, some records might be predicted by the model as negative here, and if you look at this particular cell over here, it belongs to positive. Actual values are positive but the prediction values are negative, so this would be false negative because these records have been falsely predicted as negative class, belonging to negative class. Okay, that is understanding. Now let us try to look at this. There are some records which were predicted as negative and they were negative. So these records belong to true negative. They are truly classified or truly predicted as negative class. right? This is what that means. Truly predicted as negative class. That's the meaning. So this is what I call as a confusion matrix. Right? This is what is called as a confusion matrix. All right, and there is a reason why this is called as confusion matrix, because more often or not, more often than or not, people will get confused which one is which one is which, right? So, but I'm going to give you a very simple trick to remember all of these things. Thereby, you can easily tell which metric you'll be useful in which kind of a situation, and also you will also be able to remember the metrics very easily, and you can also draw this particular confusion matrix instantly. Okay, so it's very simple. Basically all we need to look at is, let me draw this entire thing again. Okay, so you can draw a table, right? And essentially, like I said, model, a lot of data records will be given to the model, right? You have x1, x2, x3, these are the input features, and this is the actual value, and the model would predict something. So you would also have y hat, right? And let's say the model predict this as 1 1 0 1 0 0. These are the predictions, all right? And the actual values may be like this: 1 0 0 1 1 0. Okay, so if you look at this, if you look at this carefully over here, the prediction is 1 and the actual is also 1, so this is correct. Here the prediction is 1 but the actual value is 0, so the prediction has gone wrong. The prediction has gone wrong. So the prediction is 0, actual is also 0, so prediction is correct. 1 1, the prediction is correct. 0 1, the prediction is class 0 but actually it belongs to class 1, so the prediction has gone wrong. So this is right, this is right. So totally there are 4 ways in which the predictions can go wrong, which is exactly what we have seen here. So the model can predict a record that it belongs to positive class, right? And there are 4 possibilities, basically 4 possibilities, 2 of which are good, 2 of them are wrong predictions, right? So let's say the model has predicted a record as positive, and it can be correct or it can be wrong, because the actual value can be negative, so it will be wrong. And the model has predicted a record as negative, but the actual value could be positive, so it is wrong here, the prediction is wrong. So there are 2 ways in which the predictions can go wrong, right? That is, actual value is negative but the prediction is positive, and actual value is positive but the prediction is negative. So these are the 2 ways in which the prediction can go wrong, and we are discussing these points keeping in view that we are dealing with a binary class task or a binary class model. That is there are only 2 classes possible, class 0 and class 1. Okay, so if that is the case, now let us try to fill this particular matrix, right? So assume here you have the actual values, and here you have the prediction values. This is where you have the actual values, and now try to fill the matrix with respect to the prediction values. So here let's say I have positive class, negative class, positive class, negative class. So I know that the model has predicted positive for these records, for these 2, because this record belongs to positive class predictions. So I will put here as positive, and I'll put here also as positive. Okay, so I'll mark this as positive and this as positive, and I know the predictions are here as negative. Okay, so this is negative and this is negative. This entire row belongs to predictions that are negative, right? This entire row belongs to predictions that are of negative class. And now some of these can be right, some of these can be wrong, based on what the actual values are, what's the actual classes. So now let us look at this and fill that. So these are positive and the actual are also positive, so these are the true, these are called as true positive. The prediction is positive but the actual is negative, so these are called as false positive, falsely predicted as positive, right? Because the actual is negative. And this would be denoted as false negative, because the actual is positive here, and this is true negative. So this is how the basic way you would fill a confusion matrix, right? And now from this we would be able to get 3 particular important metrics, which are accuracy, precision, and recall. Okay, so let's look at the formula for this. So accuracy is nothing but the total number of correct predictions by total predictions, right? Let me write this roughly over here. Total number of correct predictions by total predictions. Okay, so if I try to fill this as per the formula, so can you tell me what are the correct predictions over here? The correct predictions would be this one, because it is truly predicted as negative, and also this is the other correct prediction which is truly predicted as positive. Okay, so that is true positive plus true negative divided by total number of predictions. The total number of predictions would be this plus this plus this plus this, right? So I'll just write it as true positive plus true negative plus false positive plus false negative. So this is simply the formula for accuracy. So let us see what is precision now. Precision, always remember that this is with respect to predicted values, right? Or that is with respect to the model. Okay, it means, what I mean by this is that of all the times a model has predicted that these records are positive, how many times was it right? Okay, so let me write it. Number of times model predicted as positive class. So this in the numerator would be number of times model is correct. Okay, number of times the model is correct. So let us try to look that with respect to the matrix over here. So let's see how many times did the model predict as positive. That would be this and this, because the model has predicted these many as positive and these many as positive, these many records as positive. So this plus these, if I add this plus this, that gives me the total number of times the model has predicted as positive class, right? The total number of records. So let's say I have here 1000 records. Out of 1000 records, maybe 400 records belongs to true positive, 200 belongs to false positive, and then 200 here. Okay, and then another 200 here. Okay, this could be how the model has predicted, right? Which means out of the total 1000 records, 600 records, for 600 times the model has predicted that it belongs to positive class. Out of 1000 records, 600 records were predicted as positive class, and the remaining 400 records, 200 plus 200, 400 records were predicted as negative class. Okay, but out of these many times, how many times was the model right? That is called as precision. Okay, precision is always with respect to the model. Remember like this, precision is always with respect to the model. Okay, so model predicted 600 times positive. Out of these, how many times is the model right? The model is right these many times, true positive, which is 400 times. So 400 by 600 is the precision in my example over here. Okay, but with respect to formula, if I write it, it will be simply true positive by true positive plus, can you guess what will be over here? False positive, isn't it? Because the total number of times a model predicted as positive will be true positive plus false positive. Okay, this is the formula for precision. Great. Now what is recall? Recall you can remember as it is with respect to the actual values. With respect to the actual values, that is, of all the positive records that belong to positive class, actually, of all the records that belong to positive class, actually, how many of them were correctly identified by the model? Right? How many of them were correctly identified by the model? So if you want to write in simple form, that is, it will be, let's say, number of times actual positive. Okay, and here number of times model correct prediction. Okay, so that would be simply in the denominator. Try to take a guess over here. So how many actual positives are there? So that would be this. Actual positives are these, right? In of these 600 positive records that belong to positive class, of these 600, 400 more or less correctly identified, but 200 more or less predicting wrongly as negative. Model is predicting wrongly as negative, whereas it was actually positive. Okay, so total number of actual positive classes, total number of records that belong to actual positive class is this plus this. Okay, so that would be true positive plus false negative. False negative means actual is positive. Falsely predict as negative. Falsely predict as negative, which means actual is positive. Right? That's what I want, right? Total number of actual positives. And the denominator or numerator will obviously have true positive. So this is nothing but recall, right? This is recall. So apart from this, there are other metrics also. For example, F1 score, and we also have ROC curve, AUC curve, which is little later we will use this to compare performance between different models actually, not with a single model, right? This is to compare performance of a single model with different hyperparameters, right? This will come a little later. F1 score is nothing but, in simple term, harmonic mean of precision and recall. Harmonic mean. So harmonic mean of two numbers is nothing but 2xy by x plus y, right? That is harmonic mean of x comma y is 2xy by x plus y, right? So based on this formula, F1 score will be simply equal to 2 times of precision into recall divided by precision plus recall. This is what is F1 score. And we will use F1 score when both precision and recall will be considered as important. Okay, when both will be considered as important, precision and recall, right? So there are many metrics over here. For example, I have accuracy, I have precision, I have recall, F1 score, ROC. There are other metrics also, like cross entropy, binary cross entropy loss. There are different kinds of metrics, but which metric to use, right? Which metrics to use to evaluate the performance of a model, and when to use which one, that is also very crucial to important, and it is a must ask question ask question in the interview, right? Because it's not enough that you just build a model. You should be able to evaluate your model to know how good the performance of the model is, and you should know which metric to use, which is the right metric to use to evaluate the performance of the model. That depends on a lot of factors, like what is the business case, what is the use case, what is more important, based on that, and we will see some examples to understand that. So to give an example over here further, this is what the confusion matrix looks like, and here we have different records, and for all of the records we have the actual data, and we also have the model predictions here, and the predictions can be right sometimes like this. The prediction is right, the predictions can be wrong here, for example like this one, and for example like this one. Okay, and there are two possible ways in which the model can go wrong. That is, actual is negative but predicted as positive, actual is positive but predicted as negative. So we have true positives. Okay, let's talk about the number of ways in which the model can go wrong. False positive, falsely predicted as positive. False negative, falsely predicted as negative. So these are the two possible ways in which the model can go wrong, because we are dealing with two binary class over here, and the model can be right like this: true positive, true negative. Okay, and the precision and the recall, in this formula here we have discussed that it is nothing but the total number of times model predicted as positive class in the denominator. Out of these, how many times was the model correct, right? And here why did I mention only positive class? Is it only for positive class that I calculate the precision? No, we can do it for negative class also. Okay, so let me write this here: positive slash negative. Okay, and here also again actual positive slash negative. That is, I can calculate the precision with respect to class 1 and also with respect to class 0, right? With respect to class 1 and class 0 precision, and recall also with respect to class 1 and class 0. Okay, so whenever somebody asks you about precision, you can immediately remember instantly that actual values are in the columns like this. Okay, so think of the column, right? And the denominator will, okay, sorry, precision, if you talk about precision, that is with respect to the model predictions. So the model predictions are here in the row. So think about the row, right? So this plus this will be in the denominator, because that is the total number of positives. True positive plus false positive, total number of positives that the model has predicted, right? That is the total number of positives predicted by the model in the denominator. In the numerator, it will be simply the correct predictions, that is true positive. And when somebody asks about, let's say, recall means with respect to actual values. So that would be within the column side, because actual values are in the column. And now here you can just add this plus this. That will give you total actual positives. That is nothing but the denominator. And the numerator will be correct predictions, that is true positive. Okay, so recall is simply, I can look at this, I can tell true positive by true positive plus false negative. Precision is simply true positive by true positive plus false positive. Okay, the only difference between the two is that here you have false positive for precision, you have false negative for recall. That's it, right? And accuracy is simply the total correct predictions by total number of predictions, total, all of the predictions. It is not with respect to positive class or negative class, it is with respect to everything, all the predictions. That is accuracy. So precision is with respect to this class or this class, right? Positive class or negative class. Recall is also with respect to this class or this class. Okay, but accuracy is on the entire data, of all the predictions. How many times is the model correct? So true positive plus true negative by true positive plus true negative, false positive plus false negative. Okay, this is what is accuracy. F1 score is nothing but harmonic mean of precision and recall. So 2 into P into R by P plus R. This is F1 score. In the next video, we will take an example and understand when to use accuracy, precision, recall, and even F1 score. Thank you.